Hello everyone, welcome back to another topic on Python. It's OOPS, Object-Oriented Programming. Till this point, you have seen what is language fundamentals in Python. So we have covered what is variables, what are the instructions of variables, what is loops, what are functions, and different topics in conditional statements, etc. So now it's time to understand the basic fundamentals of Python called OOPS. So, what is OOPS exactly? OOPS is nothing but object oriented programming. In the real world, everything is object, whereas laptop is an object, where a mouse is an object. If you consider, if I'm recording in the camera, so the camera is an object. Everything what we see is an object, right, in the real world. So, we consider this entire world problem is considered as object oriented program, and we deal with these objects. So without further ado, we'll dive deeper into object oriented program. We'll try to understand what is object, what is class, and what is polymorphism and abstraction, etc. So what is object oriented program? Object oriented programming is nothing but programming paradigm based on the concepts of objects, which is containing an attributes and methods. Attributes are nothing but a fields, or consider an human, for example, a G1. So what are the attribute of G1? The attributes of G1 is nothing but the height, weight, and qualification, age, and first name, last name. So these are the features, these are the attributes. And we also talk about the methods. What is methods here? Methods are nothing but just like a function or the behavior of the particular person, where the person is walking, eating, talking, chatting, etc. This is what methods. In general, if you are using a Python programming, we call it as functions, right? We have already talked with functions in the last topic. So if you are using the same function in object-oriented programming, that is called methods. So OOPS allows you to write the structured way of writing the code, so that makes the organizing the code very easier, simpler, and you can manage the entire project. So the major key principles of object-oriented programming are encapsulation, abstraction, polymorphism, inheritance, objects, and as well as class. We'll try to understand each and every topic step by step. Now we'll talk about what is classes and as well as what is objects in OOPS. We can see over here where as an human, right, we have properties of the human such as name, age, gender, city. As I mentioned before, these are the attributes of the particular person as an human, right? So this is called a class. Class or nothing but just the blueprint of the particular object, right? So what is this blueprint and what is object and what is class? You may be confused. Let me make it clear, right? So for example, consider we have laptop, and this laptop is of MSI. So now I can have multiple MSI laptop. For example, consider we have like almost 10,000 or 1 lakh of laptops that has been manufactured. So this laptop I can use and I can see. This is what? This is an object where I can see my particular laptop and I can use it. But actually, while building this laptop, they first design it, right? So that design we call it as class. Before building any object, first we want to design the class. So that is what class and as well as object, right? So now if you want to talk about the methods as I mentioned before, in object oriented program, methods are nothing but a function. So the properties does some methods, right? Where the name does is a property, where walking is nothing but the function or nothing but the behavior of the human. Walking, sleeping, speaking, eating, these are the behavior of the particular human. So this we call it as methods. So below you can see where we have provided some details with an example, where the properties or the attributes or name is Ron, where the age of the Ron is 15 years and gender is male and city is Delhi, right? So if you want to define the methods on top of that, you can write it as can walk, you can speak, you can sleep, and you can eat. So this is what a object and as well as class, what I mentioned was. So as I mentioned here, a object is nothing but an inheritance or is an instance of the particular class. A class is nothing but a blueprint of creating any object, right? So it defines the properties, attributes, and as well as behavior, that is methods, that can be object that creates a class. An object is nothing but an instance of class. It concretes the entire based out of classes. So basically we have four pillars of OOPS, object oriented programming. So the first thing is encapsulation, and next we talk about inheritance, and we have polymorphism, and we have abstraction. So what is encapsulation and how we can use the encapsulation? And encapsulation is nothing but building the data and methods that operate on the data within the one unit. That is nothing but class. What is inheritance then? Inheritance is nothing but creating a new class from an existing class. That is what inheritance is all about. So from the parent class, you are creating a child class. That is what inheritance. From the parent, it is coming to the child. Next, we talk about abstraction. What is abstraction? Abstraction is nothing but hiding the complex implementation details and showing only the necessary features to the end users. Where we are not displaying all the information, we are hiding the complex inheritance or complex implementations, and we are just showing the necessary features. And finally, we have polymorphism. Polymorphism is nothing but using a single interface to represent the different data types. By using only one interface, you're specifying or you're displaying different data types. That is called polymorphism. So before talking about in detail of encapsulation, we'll move on to the Python programming, and then we'll try to do some of the object and class examples, and then we'll come back to the encapsulation and try working on encapsulation. So without further ado, we'll move on to the Jupyter notebook. So let me open my Jupyter notebook. Let me create a new folder. To create a new folder, you want to click on new, and you can see there is a folder. Let me go to the desktop, and then I will go for new, and I will create a new folder. So I will name this folder as oops, and let me open this particular folder. So in this folder, let me create a new file, Python notebook. So let me rename this particular file name as oops. So now let me explain you what is oops. So as I mentioned, what is oops? Oops is nothing but an object-oriented programming. Oops is a programming language or a programming paradigm that organizes the entire software to design in detailed analysis or the design in detailed functionalities of the data, right? That organize software design or on the objects. Rather than using the functions and as well as logic, right? Rather than functions and logics. So what is the helping of use, or what is the advantages of use? It helps to create the reusable of the module multiple times. It is helpful to creating helpful for creating reusable and modular coding. So this is what OOPS is all about. Now we'll talk about what is object and as well as what is class. So as I mentioned before, an class is nothing but it is a design or it is a blueprint, whereas objects are nothing but it is the real instances where you can see, right? So objects and classes. So class is nothing but it is a blueprint, for creating an object so it defines the properties or nothing but attributes. As I mentioned, the objects or the class are used to create an attributes or the properties of the particular object, right? So it is used to, it defines the properties. This is nothing but an attributes. Attributes are nothing but fields like height of the person, weight of the person, and all other details like gender, age, all these parameters. And behaviors. Behaviors are nothing but a functions that you write inside the OOPS. That is nothing but methods we call, right? That the object created from the class. So now we have written what is class. Now we'll talk about what is object. So the objects are nothing but it's an instance of a class, right? Objects are nothing but it is an instance of a class. It is a concrete entity based on the classes or the blueprints. So this is what objects and as well as class. So now we'll take an example of what is object and as well as what is class, how to create an object and as well as class. So to create an object and class, what you can do, you can first define it. So let me define my class name as dog. So class, I'm defining class here. So the class, I'm printing it as dog. So you want to write the class and the name of the class and you want to use colon because you have multiple statement below. Once you have written the colon, now I will, this is your class. So now I want to write the behaviors or nothing but methods. That is nothing but functions, right? That we used to call before, right? So I want to add that functions. So now I will use, instead of function, I will call it as methods because now we are dealing with object oriented program. So let me write the method stating that def, let me define it a function. So I will write init, let me call for self, comma, let me take two attributes, one is name and the age. So again I have multiple statements, so I have done colon again. So self dot name is equals to, I want to provide the name of the person and as well as it takes age of the person, right? Self dot age is equals to age. So now I have defined a first function or the first method. I will define the another method defining what is the behavior of the particular dog. So the behavior of the dog, what it does, it bark, right? So let me define the another function called bark. So let me provide it as self. So these are the attributes, that is name and the features, or name and as well as age. These are the attribute of the particular class. Here I am performing another function or another method. What it does? It is a behavior of the particular class. So what is the behavior? That is something called bark. So I'm asking to return. Let me write as f string here. So let me write it as in this f string. The value, let me provide it as self dot name. What dog says? Oof, right? So I have written the behavior of the particular dog. So let me call my class now. So my dog. So I'm creating an object now called as my dog. So now my dog is an object where it takes dog as the class, and let me provide the name. So name of my dog is let me provide as Tommy, and age of my dog is, let me write as 5 years, right? So now it is working successfully. Now let me print the what dog says, what is behavior of the dog, right? So let me just write as print the behavior of the particular dog. So the behavior of the dog is my dog. That is what the I'm calling my object called my dog dot. I'm defining the behavior of my dog, that is bark, right? Yeah, bark. That's what I've defined it. So let me call. Can you see the output? It is telling the name of the dog is Tommy, and what Tommy says? The Tommy says oof, right? So this is what it barks. So this is how you can create a function. Now you understood what is class. So the class names is nothing but the dog. So in this dog, it is taken the two attribute. One is name and the other one is age. Out of the name and age as an attribute, it has some behavior. That is what we have written, the behavior called bark. And now we have created into the object, and now we are calling that object. So now we understood in detail understanding of what is object, what is class, right? So everything is class in Python, right? Python do supports the object-oriented programming. Before, when we start dealing with data types, right? You would have seen the word called class before as well. How can you just write as a is equals to 25 or 23? Now, if I want to see the type of a, so I can just write as type of a. So it is telling integer, but if you just print this, print the type of a, you will get the class integer. That is nothing but it is designed and instances of int, right? So everything is class, everything is object and instances. As we've seen the four pillars of OOPS, object-oriented program. One is four pillars of object-oriented program. Pillars of OOPS. So majorly we talked about what is encapsulation. So let me write as encapsulation. What encapsulation does? It building data and methods that operate on the data within one unit or one class. It is just to build the method that operates in the one class or one unit within one unit or class. So this is what your encapsulation is all about. So let me run this. So let me make some formatting here. So let me make this as bold. So this is your first pillar, that is encapsulation. We'll be learning what is encapsulation in detail. So next thing, we also saw what is abstraction, right? So what does abstraction do? It is nothing but it hides the complex implementation, hiding the complex implementation details, and showing only the necessary forms, or showing only the necessary features, showing only the necessary features. So that is what abstraction is all about. Next, we'll talk about inheritance. So what is inheritance? Inheritance is nothing but creating a new class from the existing class that is already created. As I mentioned, parent and child class, right? Creating a new class from an existing class. And finally, we have polymorphism. What polymorphism does, using a single interface to represent the different types of data, right? Using single interface to represent different data type. So this is what polymorphism is all about. So let me give some spacing here to make look very good. So these are the different 4 pillars of object-oriented program. So now we'll try to demonstrate each and every program, like what is encapsulation, abstraction, inheritance, and as well as polymorphism. Before doing that, let me also start explaining what is abstraction and encapsulation. So let me go back to the PPT. So what is encapsulation? Encapsulation is the building of data attributes and methods that operates on the data into a single units. It allows for better control over the data access and manipulate, promote, and as well as integrate the security. So here you can see this is the class, that is person, and here we have mentioned an attribute, that is name and age of the person. So now I'm creating an encapsulation. I'm encapsulating all the data attributes and methods inside the uh, attributes, that is name and age. So I'm providing it as self.name is equals to name of the person and age of the person, and I'm writing another behavior like defining the function or the methods to display the self information. So I'm wrapping the data and methods associated with the same single units of class. That is what encapsulation is all about. It is like same like medicine, where all the medicine has been encapsulated with the wrapper, right? So that is what class and the data attributes that has been encapsulated. So the advantages of encapsulation, if I want to talk, so it is flexible programming, where you can write flexible programming. Encapsulation allows for modular and flexible programming design by encapsulating the related data and behavior within the object. It enables easier modification and maintain the code, easy debugging and testing, right? Whenever you use encapsulation, you can easily debug and you can test the code. Encapsulation facilitates the easier debugging and testing, as it limits the scope of potential errors to specific classes and as well as object. So reusability. I can reuse the same thing again and again, right? Reuse the same code again and again. So encapsulation promotes the code reusability by encapsulating the reusable components with object, allowing them to easily reduce the different parts of the program in the other programming algorithm. So now hiding the data. So whenever if you want to hide the data, you can use encapsulation to hide the internal implementation of the details of the objects. So let me go back to the script file and start explaining a practical use case of encapsulation. So the practical use case of encapsulation is where you can write as encapsulation. Now I will be taking a banking sector for your better understanding. Banking sector. So let me demonstrate how encapsulation can be used in the banking sector. Demonstrating how to use encapsulation in Python using class representing the bank account. So what I will do, first I will create a encapsulation called bank account. I will create a class called bank account. The bank account class, I will encapsulate with the attributes. What are the attributes that let me provide? I will provide you the account number and as well as what is the balance that he has, right? So inside this class, that is bank account, I will provide encapsulated encapsulates the attribute. So with the account number and as well as the bank balance. Account number with the class, and I will provide the attribute. I will ask for the attribute of account number with let me also provide here bank balance. So the next thing what I can do is I will ask for the deposit amount, and also let me ask for the withdrawal amount withdrawal. And finally, let me print the what is the remaining balance. So these are the major steps that I am going to perform now. So as a banking sector, first it takes the bank account number and as well as the bank balance that the person has. And finally, it is asking for depositing the amount or else withdrawing the amount. And finally, it is displaying the what is the remaining balance that the account has. Yes. So now let me define the class. So let me provide the class name as bank account. So this is the class that is you're providing bank account, and I'm using colon here because I want to write the statement. So once you define the class, you also want to provide the module or something, but you want to also provide the behavior or attributes, right? So let me define the function now. So functions are nothing but methods, as I mentioned before. So rather than function, let me call this as methods. Let me define the method. So def underscore underscore init underscore underscore. I will write few attributes. So let me provide self comma. So as the attribute I have mentioned, I'll be providing two attributes. One is account number and the other one is bank balance. Account number comma bank balance, that is balance. So two attributes I have provided here, account number and bank balance. and below I'm writing some statement here. Self dot underscore account number is equals to. So I'm encapsulating this particular account number as an attribute, account number, and I will also do the same thing for bank balance. Self dot balance is equals to balance. So now I have encapsulated this both the attribute, one is account number and as well as the balance. So let me define the another functions or the behaviors. So let me write as def. So here I am writing the another method by using the def as the keyword. So let me write get account number. So I am asking the account number. Account number. So here also let me provide it as self because I am using internally. So I will return self dot account number. So now I am returning the self account number. That is perfectly fine. So let me add another method. So I will define def keyword. I will write as get bank balance. I'll write as self. So return self dot balance. So now I've created some of the encapsulated data here. So once it is done, let me go back and also provide the deposited and as well as withdrawal behavior. So to provide the deposited and withdrawal behavior, again I want to create another module. So I'm writing it as def, defining the method, and next let me provide a deposit. So deposit again takes a few information. Let me write it as self, comma, amount. So I'm asking the user what is the deposited amount. So if amount, there should be a condition, right? If the depositing amount is greater than 0, then only you perform this certain task, right? Self dot balance plus equals to amount. I want to affect the original amount that already the person has. For example, the person has 5,000 rupees. Now is depositing 6,000. So my original balance should be 6,000 plus 5,000. It should be 11,000. So that's what I am mentioning here. This is nothing but the assignment operator plus equals to I have used. So I'm printing the balance. So I'm just printing what is the deposited amount and as well as the balance amount. So I'm writing it in the dot string or f string. Deposited amount. So always whenever you are using f string, make sure that the value that you are providing is in the curly braces. So is equals to amount, the deposited amount, and the new current balance is new balance or the current balance. What is the current balance? So the current balance, let me also write it as self dot balance. So now we are providing the balance. You are displaying what is the deposited amount and what is the current balance. So what if the amount is less than 0? Else, I will write an else statement. If the depositing amount is less than 0, that means it is an invalid deposition, right? So let me write as else. You want to print it as invalid deposit amount. Invalid deposit amount. So user cannot give any negative values. If it is less than 0, it should tell that invalid deposited amount, right? So now I will talk about withdrawal. So again, I want to write a condition that if the withdrawal amount is more than the bank balance, it should again throw an error by stating that insufficient balance. Always the withdrawal amount should be less than the or equal to my bank balance, right? So let me define another method here. So defining withdrawal, withdraw. So again, let me write an argument here, that is, or an attribute amount. So what is the withdrawal amount I'm asking here? So now my condition is if it is less than 0 or 0 is less than amount or it is less than equals to balance, bank balance. If this is the case, what I want to do? I want to just write as the amount that is withdraw, and then for example consider it as 10,000 and he withdraw 5,000. So now the current balance is 5,000. I want to subtract from the balance amount, right? So I want to write it as self dot balance minus equals to. So minus equals to amount that is withdrawing. That's great. So now let me print the what is the withdrawal amount and as well as what is the bank balance. That is what is the current balance after withdrawing the amount. So let me write as f string again, f of withdraw. So what is the withdrawing amount? Withdrawal amount. Let me write as withdrawal amount as amount that the user has mentioned, comma. Now the current balance. Current balance is nothing but the self dot balance. So that's great. So now we are able to provide the withdrawal amount. So if the withdrawal is, as I mentioned, the withdrawal is 3,000 and the person has 5,000 in his bank account. So what I have done, I have subtracted the 3,000 from the 5,000 and I am printing the withdrawal amount along with the current balance amount. So what if the user is providing the withdrawal amount more than the balance? So what the system needs to do? It should throw an error by stating that the insufficient balance that the person has, right? So user cannot withdraw 10,000 rupees once he has the balance of 5,000. It is insufficient balance, right? So I'm writing an else statement, else print. So in the print, let me provide the insufficient balance. Insufficient funds or insufficient balance or invalid withdrawal amount, right? If it is like printing any other numbers like less than 0, you want to write the insufficient or invalid withdrawal amount. Invalid withdrawal amount. So let me execute. So this entire system we have built. So it is running successfully. So we have created multiple stuffs. So now let me call this class. So to call the class, what I can do? Let me write it as account1. I will create an instance. Account1. That is nothing but what is the class name? The class name is bank account. Let me copy the class name because I want to call the class name first. So the class is taking the two attributes as I mentioned. One is account number and the other one is the bank balance. Let me provide my account number here. So some dummy account number I am providing here, 9123452137. So consider like I provided random account number 927653577722. So now I am telling currently I have balance of consider 10,000 rupees. So now this is done. So now what is the different actions that you are performing on top of these attributes or the methods that you have created, right? So let me write print. So before that, let me explain you what I'm doing here. I'm accessing the Encapsulated attributes through methods. Encapsulated attributes through methods. So I'm printing the account number. Firstly, let me print the account number and then let me print the bank balance that the person has, right? So print account number. So while printing the account number, make sure that you're also writing here account 1, that is the object that you have defined here. Account 1, let me copy this account 1 dot get. I want to get what? Account number. So I'm getting this account number. I'm defined here. I'm just extracting that account number. The same thing I want to do it for bank balance. Print. So consider the user is providing the bank balance, that is 10,000 rupees I have mentioned here. I'm printing those bank balance. Bank balance. So bank balance is equals to, I want to specify the bank balance. So the object, that is account 1. Let me go here, copy this account 1 and paste it here as account 1 dot, I will write get what? I'm extracting the balance from this, right? That is super easy. So if you click on enter, it is throwing an error by stating that bank account object has no attribute account number. Account number, ACCOU and the account number. So let me cross check. So this is your account number. Let me copy paste this. So why is this error? In a sense, if you see this, while defining the class, we have provided account number, and we are calling this account number as self.account number is equals to account number. So just copy this account number and then you recheck this bank account as the class that you have provided. Bank account is, everything is fine. So always make sure that you are using the underscore here. So if you don't provide the underscore, you will get an error by stating that where account is on, where there is no bank account, in the bank account there is no account number. So always make sure that you are providing an underscore here while defining it. So self dot underscore underscore account number and as well as bank balance. So can you see here? So it is able to provide you the details of account number and as well as your bank balance. So if you want to withdraw the amount, let me write it as withdrawal amount. So account 1, that is what you have defined here, account 1. So account 1 dot, let me withdraw some amount. Let me withdraw 5,000 rupees or 3,000 rupees. So overall balance that I have is 10,000. So if I withdraw 3,000, also you want to provide the same thing here for the withdrawal and as well as bank balance, right? So don't forget to use underscore here for the bank balance. Also you want to give underscore underscore bank balance, and here also you want to provide the same thing. Self dot underscore underscore balance. Here also you want to provide the same thing, self dot underscore underscore balance. So do provide the same thing. Whenever you write the self, write down underscore of the balance. So bank account has no attribute called bank balance.
Yes. So do provide, whenever you provide the self, also try to provide the underscore. So you're telling like withdrawal amount is 3000 and the current balance is 7000. So it is working fine. Now if I want to provide the deposited amount, so let me write as account 1 dot, I want to deposit some amount, deposit. So before depositing, let me see the depositing where I have used self underscore underscore and as well as self underscore underscore. Perfect. So let me deposit 5000 now. So what happens if you provide 5000? So even balance a single attribute, that is telling here, let me provide the two types underscore. So that is the mistakes, guys. Whenever you provide it, you are providing the two underscores, not this individual single. So it is telling it is 5000 has been deposited and the current balance that was previously 7000. So 7000 plus 5000 is nothing but 12,000. So this is how you are able to use the encapsulation in OOPS, object oriented programming, where firstly you have defined the class and then you have defined the methods. You are providing two attributes, one is number and the other one is bank balance. So now you are calling with a condition or with a methods. So the first condition that you have provided, that the depositing amount should be greater than 0. If it is less than 0, it should throw an error by stating that invalid deposited amount. Let me also provide here as account 1 dot deposit by minus 3000 or minus 2000 or minus 299. If I provide it, it should throw an error by stating that invalid deposited amount. Can you see here? Because we have written this in the else statement. So if the user is providing a withdrawal amount more than the bank balance, for example, let me provide it as account 1 dot withdraw. Let me write it as withdrawing 80,000 or something. So he has only 12,000 as his current balance, but if we start withdrawing 80,000, again it should say that insufficient balance, right? So you can see here it is telling insufficient funds or invalid withdrawal amount. That's what we have written in the else statement here. I hope that everyone understood how to use your encapsulation and object oriented program. So now we'll talk about the next parameters or the next fourth second pillar of OOPS, that is abstraction. So what is abstraction? Abstractions involve simplifying the complex system by modeling the classes based on the real world entities. So what is entities? Entities are nothing but living or non-living real world data objects. It focuses on essential attributes and behavior while handling or while hiding the necessary or unnecessary details and showing only the necessary information. Abstraction helps to manage the complexity and improve the code readability. So this is how the abstraction, using abstraction and without using abstraction, the data looks. So you're hiding the unnecessary information and you're displaying only the necessary information. So what is the advantages of using the abstraction? The first thing is simplification. Abstraction simplifies the complex system by focusing on essential features, hiding the unnecessary details and providing an high-level view of functionalities. So abstraction also helps in terms of modularity. It promotes the modularity by organizing the code into the abstract classes and interface, allowing the easier maintenance and scalability and reusability of the code. Flexibility, yes, in terms of abstraction, it also helps you to do the flexibility job. Abstraction enhance the flexibility by decoupling the implementation details from external components, enabling easier modifications and adaptations to change the requirements. So we'll go back with the Python programming. We'll start performing an abstraction task. So to perform abstraction, you want to follow few procedures. Let me write it down. Abstraction is your module. So let me write down here. The first task that you want to provide is you want to define the abstraction base class, define an abstract base class. So once you define the abstract base class, you are writing a blueprint of the particular class. So what is the blueprint that we have written? The blueprint is bank account. Same thing we'll write as account. We'll create a blueprint called account. Create a blueprint. So the blueprint name, let me write as account. So that enforces the specific methods in the entire module that enforce says the specific methods while depositing and as well as while withdrawing the amount. Deposit and withdraw the amount to be implemented by any solution. Or subclass. So in the subclass. So along with that, let me provide you the details of how to implement the concrete class. So implementation of concrete class. Implement a concrete class. So while implementing the complete class, you want to do the operation for the subclass of the data. So create a subclass. So consider I'm creating a subclass as savings account. Savings account. So that as an inherent value of the main class, right? That inherits from the main class or abstracted class, you can call, and provide you the concrete implementation and provide concrete implementation of for an abstract for the abstract. So third thing is we'll hide the implementation details. So no need of showing the implementation details. So we can hide some of the information or unnecessary information, right? Hiding the implementation details. So we use abstraction to hide the implementation details or else for the unnecessary information. So use abstraction to hide the internal logic which are not useful, like which are internal logics and internal logic such as withdrawal amount or withdrawal operations and savings account operations. So next thing we want to perform is encapsulate your data. So to encapsulate your data, what you can do, you can just specify before encapsulation, you want to perform the polymorphism, showcasing the polymorphism, showcase polymorphism. And fifth stage is encapsulating your data. So lastly, you're providing a detailed understanding of the particular example. Provide a practical example. Example of this abstraction. So let me run this. So now we'll do the task step by step. How to use abstraction in OOPS. So first thing, let me define a function. So let me start importing some libraries, some modules from ABC, import ABC and abstract method. So I have imported successfully. Now let me define the class. So the class is nothing but account. Inside the class account, I will provide some attribute like ABC account. So let me provide as ABC. So now I have defined the class. Now I will try to define the methods. So to define the method, you want to write as keyword as def. So underscore underscore init underscore underscore. So you want to provide some attributes here. So let me write as self, and I will also provide the account number and bank balance as I mentioned before. Account number, comma, balance. So I am using colon because I want to write multiple statement below. So now let me call this self dot account underscore number is equals to account number, and then self dot balance is equals to balance. So now we have defined it successfully. So it's working completely fine. So now what I will do, I will call this abstract method. So at the rate abstract method, let me call this, let me copy this abstract method and then let me call it here. Abstract method. Let me define another method, defining method like df. So I will write a deposit. So it will take again deposited amount. Let me write as self comma amount. So again I will use colon. So I will write some of the parameter here like pass. Do not do anything, just pass it because I don't want to mention anything for now. So that's what abstraction is all about, where you're just skipping the information. Let me write as abstract method once again. So I'm defining another function or another method called withdraw. So here also I'm writing self comma the amount that needs to be withdrawal. So again I'm writing pass. So again I'm not doing anything, I'm just skipping it, I'm just passing it out. So now I'm using a class, another class. So the first class name is account. So I'm defining another class now. So let me define the class name called savings account. Savings account. So this in this savings account, I will provide an attribute called account. That is nothing but I'm providing an other class. That is nothing but I'm performing an inheritance kind of thing, right? So previously defined class name I have provided here, colon. So let me define the method here, def underscore underscore init underscore underscore. I will provide the attribute self comma account number and also let me provide the bank balance and the interest rate. Balance comma interest rate, right? So here I've provided few functions, a few methods. So let me call it as super dot underscore underscore. I will initialize it in it underscore underscore. I will provide the account number and bank balance. So I will write it as self dot interest rate is equals to, I will provide the interest rate. Let me define the another method called deposited amount. So I want to provide as self comma amount self dot balance is should be greater than equals to amount. So while withdrawing, your bank balance should be greater than the withdrawal amount should be greater than your bank balance should be greater than the withdrawal amount. That means your withdrawal amount should be less than the bank balance. That's what I have written here. Your bank balance should be greater than the your withdrawal amount. And also let me write as print in the f dot format. I am providing let me change this to withdrawal. I'm writing, right? I'm not writing the I'm not doing a withdrawal, I'm just depositing now. So if you want to do the depositing, you want to write bank balance plus the amount that already exists. So I'm providing here deposited amount. So what is the amount that they are depositing? Amount, and then what is the current balance? So the current balance is nothing but self dot balance. So now we have provided the different method here, that is deposited method. Now let me create another method called amount withdrawal. So I'm defining the method again, def keyword withdraw the amount, that is self comma what is the amount that is withdrawing amount. So here I'm writing I'm writing a condition f self dot balance. The balance should be greater than equals to the current balance. Right? Always make sure that you are writing the balance amount should be greater than equals to the withdrawal amount. So you are writing colon self dot balance minus equals to. Why I am using minus equals to in the sense, because I don't want to see this balance. For example, consider if he is withdrawing 5,000 out of 25,000, so the current balance should be 20,000. So I want to subtract the withdrawal amount from the bank balance that is available. So let me make sure that minus equals to the amount that it has. So I want to write print what? I am writing dot format withdrawal amount comma and the current balance is equals to, I am writing the current balance is nothing but self dot balance. So finally I want to write an else statement. If the withdrawal amount is more than the current balance, I want to go with print it as insufficient balance. Same logic that I have explained before. Insufficient funds So let me execute this. It is working perfectly fine. So here we have used first you have created the class and then you have created the different attributes where it takes two attributes, one is account number and bank balance. So I've used abstract method here to just skip this information, and again I'm creating another class. So I'm providing an inheritance over here and I'm performing the same operation in the savings bank account. So let me call the class. Let me create an object as variable name as savings account. Account is equals to, so this is your savings account. Let me copy this class. Let me paste this class. I want to provide the details now. The random bank balance, comma. One is bank balance it is taking, and the other one is it is taking the account number, bank balance, and as well as interest rate. So account number I have provided, bank balance is 25,000, comma, interest rate is 0.05. That is nothing but 5% of the interest rate I have provided. So let me execute it. It's totally working fine. Now let me call this abstract deposit amount. So to perform the abstract deposit amount, let me write it as a savings account, that is a variable that I have provided here. Savings account dot deposition amount of how much amount I am depositing here. Let me deposit 5,000. So can you see here? Here I am depositing 5,000. Now the current balance got changed to 25,000 to 30,000. Now let me make sure that I am withdrawing some amount. So let me withdraw 25,000 or 20,000. So once you withdraw 20,000, your current balance should be 10,000. So let me write as savings dot account, savings account, that is what here the variable that I have mentioned. Let me copy paste it, dot withdrawing amount, let me say that I am withdrawing 20,000 amount. So can you see here, once you withdraw 20,000 amount, now the current balance is 10,000. So it is totally working fine. I hope everyone understood how to use the abstractment inside the different class, right? So where we have start explaining what is your object, what is the class, and also we started explaining what is abstraction and what is inheritance. And also we covered what is encapsulation. So we'll move on to the in detailed understanding of what is polymorphism. So polymorphism is nothing but where it allows the object of different class to be treated as an object of a common superclass. So it enables the flexibility in method implementation, allowing the methods to behave differently based on the object's type. Polymorphism is achieved through method overriding and as well as the method overloading. What is the advantages of polymorphism? The advantages of polymorphism are code reusability. So you can reuse the code, flexibility. So yes, if you use polymorphism, it will be more flexible, and then simplified code maintenance. Yeah, after using polymorphism, the maintaining the code is very simpler, easier, and you can perform various tasks by using polymorphism. So let me go back to the Jupyter notebook and let me take a simple example of animal and let me explain you how it works. So animal with different type, right? So let me write down different class called as different animals like dog and cat, etc. And let me make sure that how the sound of dog and as well as cat varies, because these are the different class or different objects, so how they behave. So let me take it on practical examples of different types of animals. So let me first define a class. So the class name I am providing it as animals. So as I mentioned, first when you define the class, below that you want to define a method. So let me define a method called def sound. So let me first write as self. I am passing this. I am not doing anything. So I will define another function or another class called dog. So this dog takes the previous class information, that is animal. So inside the class, I am writing an previous defined class, that is inheritance. I am performing here. So I am writing it as another module of called def as the keyword. So how it sounds, right? It sounds self, and I am returning bark. So dog sounds like bark. So now let me define another class. So let me make sure now the class is the class name is cat. So let me class, even cat is also is an inheritance of animal, right? So I want to make sure that even the cat is also inheritance of animal. So I will write the animal class here. So I'm writing an again method called sound. I'll write as self. So how it sounds? It sounds, I'm returning as meow. So this is how we have defined the function. Now we define the polymorphism. So defining make sound of animal. I want to print animal dot sound. I'm printing the animal sound. So you have defined it. Now let me create an instance for different animal sound. I'm creating an instance called dog. So I'm providing the dog function, and as well as I'm creating an instance called cat, and I'm calling the function called cat here. So the cat, I've called it in the, I've defined it in the capital C, and I'm calling it in the small c. Okay, now I've called it. So now I'm using a polymorphism called make sound. It is not sound, it is sound, right? Make sound. I'll copy this and I'll write it as make sound. So let me call this instance of dog. So make sound of dog is nothing but, can you see here? It is printing it as bark. If you do the same thing for cat, you'll get the output as meow, right? So this is how we can create an class. Inside the class, you can create multiple methods, and you can perform some inheritance. Here we have performed an inheritance. That is nothing but both animal, cat and dog is the inheritance of animal class. So this is the use of this is the purpose of using the inheritance. So I hope everyone understood what is polymorphism here. So now the last topic is inheritance. So inheritance is nothing but it is the mechanism where new class, where the subclass are divided into multiple classes, where it inherits the properties of the parent child to child class. So the advantages of using the inheritance is the code reusability, simplified maintenance, and as well as extensibility. So let me create a demo of inheritance. Demo of inheritance using the class which are representing all the animals, right, or the vehicles. I'm creating an inheritance which allows me to understand the various vehicles details. So first let me define the vehicle as the class name as vehicle. So now let me define the method by using def keyword underscore underscore init underscore underscore. So let me write as self comma. So let me ask the two argument to or two attribute. The first attribute is the brand name and the second attribute is the model. Brand comma model. I will enclose this. So let me write as self dot brand is equals to brand details, and as well as let me write as self dot model is equals to model details. So this is super cool where I've created the class name as vehicle and I've created the method which takes two arguments or two attributes. One is brand and as well as model. So now let me call this like, let me provide def method display the info. I'm creating another method called display info for self. Let me print brand is equals to self dot brand comma model is to self dot. So let me cut this information and then let me specify this inside the bracket, right? Self dot model. So this is perfectly fine where we have created two methods. Now I will also create another class name called car. So car is also the inheritance of the previous class, that is vehicle. So let me write the vehicle inside the class car. So let me define another method called initializing self comma brand name and model name. Along with that I will also specify here number of doors that we have. So brand comma model, along with that doors, number of doors that we have, right? So colon. So let me specify here super, that is nothing but I am taking an inheritance here dot underscore underscore initializing it with brand and model. So I want to take the inheritance of the vehicles that has been previously defined. I will want to take only the brands and as well as models, because I have called here brands and models. But here I have not defined the doors, number of doors, because it is not the attribute that was provided. But here I have provided the doors as an attribute. So I also want to explicitly mention here self dot doors is equals to doors. Got it? So what is the super is doing in the sense? Super is printing what is the previously called attribute, that is printing the same thing for this. So now let me define this model called display info of self. So again for the display info I will do the same thing. I want to take super, that is inheriting the previous models that has been created. I will write super dot display underscore info, and let me write as print f, that is a dot string, doors equals to, I will specify the self dot doors. So now we have defined this car where the vehicles instances. Now I will write it as motorcycle. So let me define the another class called motorcycle. So this motorcycle is also taking the use of vehicle as the inheritance values. So I will copy this vehicle and then I will write it inside this class. So I will define this method def underscore underscore init underscore underscore. So I want to define it like self. I am taking an again 3 parameters. One is brand and model and as well as type. Brand, model and as well as I am taking type. So it want to take the inheritance of only the brand and model but not the type. So let me write as super dot underscore underscore init underscore underscore. So I want to take only the inheritance of brand and as well as model. So let me write as self dot. I want to create a new class for type. Self dot type is equals to you are providing the type information. So now let me write it another module called defining a display model display underscore info. So it is taking self as the method. So I will perform super dot display underscore info. So let me print the dot format f. I will write as type. Let me specify the self type. So self door we have specified before. Now we are writing self type. Why this self door? In the sense before I've called it as door here. Door was not present, so I've called the self door. Now I want to call the self dot type. So this is executed successfully. Now we'll try to also extract the information of or we'll call the instances. This is the entire thing that we have created. Now we'll try to call the instances. To call the instances, I can just write as car is equals to, so instances name I provided as car. So I want to call this class that is capital car, C-A-R, and let me provide the two attributes. So the car is taking two attributes. One is three attributes. One is brand, model, and as well as doors. So let me provide the brand name of this particular car is Toyota, and also let me provide the model, and also let me provide the doors. So we have 4 doors in that. So let me execute this. So it is working successfully fine. So I will do the same thing for motorcycle. I will create an instances called motorcycle is equals to, I will call this particular class that we have created. So motorcycle again takes how many arguments? It takes 3 attributes. One is brand, model, and as well as type. So let me provide the brand name as Yamaha, and let me provide the model. The model is MT7. Let me take it as MT07. I hope you have heard about MT07 bike, right? So I'm taking that particular model, and this model is nothing but what type of bike is this? Is a sports bike. Sports bike, right? So this is working totally fine. So now I'm displaying the information of the inheritance. So let me call it as car as the instance dot display underscore info. So can you see here when I call the car dot display info, it is providing me the all the brand details and as well as model that has been specified. So if I write as motorcycle as the instance, let me copy this motorcycle and let me specify this motorcycle instance dot display info. So again I want to get the motorcycle instances, that is nothing but Yamaha and as well as MT16. So this is the functionalities of using the particular class and as well as particular instances for each and every topic. So whenever you call the display info, that provides the display details here. So if you also want to make sure that you are providing the display of self here. So let me go back with all the topics and make you clarify better. So the first thing what we have learned, we try to understand what is OOPS. OOPS are nothing but an object oriented program. Whatever you write in the Python, it's all about, it accepts the OOPS, because whenever you define any data types, so that is an object that you are defining. How to check whether the data is an object data type or not? You can see here, let me print it as A is equals to 25 or 23. So type of, print the type of A, that is nothing but the type is class, right? So class or nothing but you're telling the design of the particular instances, right? So this is your class. So we understood what is the class and as well as what is object, and we also try to understand what are the 4 pillars of particular OOPS concept. One is abstraction, and then we try to understand what is abstraction, and we also understood what is encapsulation. We are very clear with what is inheritance, and as well as we try to understand what is polymorphism. We took some of the examples of how to create a banking sector by using the abstraction and as well as encapsulation. So by using the encapsulation, we are able to clearly extract the information, and we also try to perform an operation by using the abstraction, and we tried solving by using the polymorphism and as well as by using the encapsulation. So this is the detailed understanding of OOPS, object oriented program. Thank you.